Hello everyone. So for this lesson we are going to basically change the format, the form of the quadratic function from one form to another form. Let's start with changing it from vertex form to general form, just that you see what is happening. So we have this example here. We have this quadratic function. We want to change that to the general form, which it looks like ax squared plus bx plus c. Okay, and that's what we have the vertex form, and this is the vertex form. Okay, so this is the vertex form. I want to make sure that, and this is the general form. So let's do that first because this is easier. So let's go ahead and let's do the math on this one. So what it means is that you just have to basically expand and multiply and collect like terms, and at the end of all of that simplification you must have the form y equals to ax squared plus bx plus c for some values of a, b, and c. All right, so basically that's what we want to get to. So first thing first, let's do, so we're following BEDMAS. We have to expand the bracket, so that would be x squared minus 2x plus 1, close the bracket, plus 3. Okay, that's the first thing you have to do. So x minus 1 all squared is this trinomial. That's a perfect square trinomial. Next, multiply minus 2, negative 2 into the bracket, one term at a time. That's what we got to do. So here we go, minus 2x squared plus 4x minus 2. The bracket is gone, and then plus 3. Great. Last step, collect like terms. Minus 2x squared plus 4x, and this would be plus 1. Rewrite the equation in the general form. Minus 2x squared plus 4x plus 1, that's equals to y, and this is the final form, which looks like that. All right, so we just went from the vertex form to general form, and we just followed it. Okay, that's what we did, and very simple. As long as you follow the BEDMAS process, you should be able to go through it. All right, okay, so now we have this general form of a quadratic function. We want to change that to its vertex form. All right, now you can look at it and say, oh, we just did this question. Maybe we did we? Yes, we did. So we're gonna go backwards. So we're just now going to go from the bottom to the top. Okay, so that's what we're gonna do now. Excellent. The method that we're going to use to change the general form of a quadratic to the vertex form, we're going to use the completing the square method. And this is the method that we actually use to solve quadratic equation. This was a method actually that we used to derive the quadratic formula, to do the derivation of quadratic formula. All right, just a reminder. So if we have this first, this expression x squared plus 6x plus, there's another term here. So this is basically a trinomial. We want to make this trinomial a perfect square trinomial. Okay, so how do we make this a perfect square trinomial? And remember, perfect square trinomial, it means that when we do the factoring, we have both brackets, so both of these brackets will be the same, or the same bracket squared with the binomial inside. So remember that the process was that you take the coefficient of the linear term, 6, so that's the first thing that you have to do, and then you divide that by 2, and then whatever you get, you square that and add here. So this would be 6 divided by 2 all squared. 6 divided by 2 all squared, so 6 divided by 2 is 3, 3 squared is 9, and then when you go ahead and you put it in here, it would be x plus 3 all squared, and that gives you the perfect square trinomial. So we are going to use exactly that to change the form from general form to the vertex form. All right, let's go ahead and start with this. So we have, let's go up. So let me rewrite this. Y equals minus 2x squared plus 4x plus 1. All right, so the first thing we want to do, we want to isolate the first two terms. All right, we're going to leave y alone. We're not going to touch that. We're also not going to touch the plus 1, the constant term. So we're going to separate minus 2x squared plus 4x. We're going to leave it like this, and I'm doing it on purpose right now. There's a little space in here. But before doing that, so I'm going to put it in a bracket like that. All right, so that's on its own. We have this minus 2 in front. This minus 2 needs to go away, but we just can't take it away and that would be it. No, you have to be mathematically, it has to make sense. So we're going to factor that out. So let's factor the minus 2, negative 2, out of both of the first two terms. So that gives you x squared. And the next piece will be minus 2. We're just going to factor the negative 2 out. We're not doing a GCF, just the coefficient, the leading coefficient for the quadratic term. That has to come out. So when we do this, so we are factoring just from the first two. Close the bracket again. Okay, plus 1. And remember, we will be adding something to here so that makes it the perfect square trinomial. Great. All right. So now let's look at this inside of this bracket. What should we add to this two terms, first two terms? So the third term should be what? So that makes it the perfect square trinomial. We're going to follow the same path, same routine, same process. Half of minus 2, that's 1, negative 1 is squared. So plus negative 1 is squared. Okay, that's the first thing that you have to do. Then we have to balance this equation. We can just add stuff to one side of the equation and don't do to the other side, or we can just add 0 to one side of the equation, and that's okay. So if whatever we do right now, we have to neutralize that. Okay, we have to undo it because we don't want to put it to the other side. The other side has y anyways. We're going to leave it like that. So what is it that we do? What is it that we did here? We added 1 inside the bracket, but actually we subtracted minus 2. That was minus 2 times 1. So if we subtracted that, we need to neutralize that by adding the opposite. Okay, so that's what we were doing. So now we're going to rewrite minus 2 is outside. We're going to change that to the binomial squared. Remember this negative middle term, that's where that comes from, squared. And then the last piece is when we're adding these two, that would be plus 3. Okay, now let's see if we did it correctly. All right, let's go back up. This is minus 2, x minus 1 all squared plus 3. All right, here it is, minus 2, x minus 1 all squared plus 3. That's exactly what it was, the original. Excellent. Now, why do we need the vertex form? Because you can get the vertex from that, okay? And it's very important. We can basically come up with all the necessary information so that we can actually graph this accurately. So what is the vertex in here? Just while we are at it, is positive 1 and 3. The axis of symmetry is equal to 1. You have the graph opens down. And why is it opens down? Because we have the negative in front right here. That's the negative. All right. And the 2, you got the vertical expansion. And basically you have all the information. Now then you can go ahead and graph. All right. So be aware, the hardest part of this is when you are multiplying whatever the leading coefficient is to whatever that you add or subtract inside. You're actually adding inside. So if there is no leading coefficient except 1, you don't have to worry about that. But if there is, you must take that one into account. Okay? All right.